You know that big, bright yellow slide you see in every single airline safety video? It's a piece of gear we all recognize, but really, really hope we never have to use. But behind that simple-looking inflatable is this whole world of incredible engineering and super strict rules, all governed by one critical idea: the 90-second rule. And you know what? Sometimes it all comes together perfectly. Just think back to January 2024. After a horrifying, fiery crash on the runway in Tokyo, all 379 people on Japan Airlines Flight 516 got out safely. It was just a textbook example of the entire system: the crew, the passengers, the equipment working exactly the way it was designed to, even in the absolute worst-case scenario. So how in the world did they pull that off? Well, that's what we're going to break down. We'll look at the story of that incredible escape, then we'll dig into the rule that shapes every single evacuation. We'll explore the ingenious invention that makes it all possible, talk about the unpredictable human factor, and finally, look at how one tiny change in instructions could make flying even safer for all of us. All right, let's start with that real-world disaster that turned into a miracle. Section 1, a miraculous escape. The JAL 5016 incident is now, and for good reason, a gold standard in aviation safety. And make no mistake, this was not luck. It came down to three absolutely crucial things working in perfect harmony: a crew that was incredibly well trained, passengers who actually listened and followed the rules, and of course, the safety equipment that we're talking about today. This is the best case scenario everyone trains for. And that incident really puts a spotlight on the regulations sitting at the very heart of how we certify airplanes. Which brings us to Section 2, the 90-second rule. It's the benchmark for every single evacuation, but it's a rule that some new research is starting to raise some serious questions about. So what is this rule exactly? Well, it's a requirement from aviation authorities like the FAA, and it says that a manufacturer has to prove that a completely full plane can be emptied in a minute and a half. But here's the real kicker: they have to do it using only half of the emergency exits. Why? Well, they're simulating a real disaster where fire or damage might have blocked some of your escape routes. It is a seriously tough standard. But here's the thing: the people who fly today aren't the same as they were decades ago. So it leads to a critical question. Is this rule still a realistic benchmark for the passengers of today? Well, recent research from the universities of Sydney and Calgary suggests maybe not. They ran a computer simulation of an evacuation on an Airbus A320, but they packed it with a large number of passengers over 60, and in their best-case scenario, the fastest they could get everyone out was 141 seconds. That's nearly a full minute over the target. It really shows you there might be a pretty big gap between the rule and reality. Now, to understand how airlines even attempt to meet that 90-second goal, we have to look at the primary tool they use to do it. That brings us to Section 3, an ingenious invention. The history of this thing is actually pretty fascinating. Before the 1950s, planes had these heavy, clumsy canvas slides that took forever for the crew to rig up. That all changed in 1954, when a guy named James Boyle, who, by the way, also invented the Mae West Life Vest during World War II, patented the first inflatable escape chute. Then, in 1965, Qantas pushed for the next big leap forward, combining the slide with a life raft for landings on water, a total game changer. So today, that's evolved into four main types of evacuation gear. You've got your basic inflatable slides, the combined slide rafts that come with survival kits, and even inflatable ramps for those huge over-wing exits on planes like the 747 or the A380. The way this thing actually deploys is a marvel of engineering. When the crew arms the door before takeoff, they're basically hooking the slide pack to the floor. If that armed door gets opened in an emergency, the whole pack gets yanked out. The weight of it falling pulls a pin, which releases compressed gas. That gas shoots into these things called aspirators, which then suck in massive amounts of outside air, and whoosh, the entire slide inflates in just 5 to 10 seconds. It's an incredible, automatic, life-saving chain reaction. So we've covered the hardware, that as those simulations showed us, the technology is only half the battle. That takes us to Section 4, the human factor. And to be fair, the regulators do try to account for the human element. For a plane to get its 90-second certification, the group of test passengers has to meet some really specific demographic quotas. They need a mix of genders, a big chunk of people over 50, and they even use life-size dolls to represent infants. The whole idea is to create a realistic mix of travelers. But that new research suggests those quotas might not be telling the whole story.
The study from Sydney and Calgary found that it's not just about the number of older passengers on a flight, but also about where they're sitting. If you have a bunch of them concentrated in one area, it can create huge bottlenecks, slowing everything down and causing a pileup at some exits while other exits go unused. So if the distribution of passengers is such a huge deal, it leads to a fascinating new question, which we're going to explore in Section 5, nearest versus optimal.
Okay, check this out. A study from Sweden's KTH Royal Institute of Technology simulated 2 different ways to evacuate. On the left, you see what we do now. Everybody goes to their nearest exit. Look at that massive traffic jam clogging up the middle doors. Now look at the right. Here, passengers are directed to an optimal exit to make sure each one is used evenly. The flow is just visibly smoother, no question. So let's just break that down. The nearest exit strategy is what we're all taught. It's intuitive. It's what you'd naturally do. But as we just saw, it can cause these crippling log jams. The optimal exit idea, on the other hand, isn't something you do on your own. It would need direction from the crew or maybe even smart lighting systems. But the result is a much more even flow, which leads to faster and, this is key, more predictable evacuation times. The KTH study basically proved that this works. Their conclusion was that this optimal strategy makes evacuations significantly faster. And get this, the effect was even bigger in scenarios where some of the exits were blocked, which is exactly the kind of situation the 90-second rule is designed to test for. So the big takeaway here seems pretty clear, right? Improving air safety isn't just about building better hardware or faster slides. It's also about developing smarter rules, rethinking our instructions, and adapting our strategies to how real people actually behave under immense pressure.
And this all brings us to one final big question. The Japan Airlines evacuation was proof that the current system can work perfectly, saving hundreds of lives. But as all this new research highlights these new challenges, we have to ask, as the world changes and the people flying in it change, are our fundamental safety rules keeping up with the reality of who is actually on board?